So today we'll discuss about some important components of the fire heaters, that is the furnaces. These are the parts that is used to assemble, to design the complete furnace, complete fire heaters. So the first is tubes or pipes. As we know that this is one of the important one. The second is the manifolds, third is flanges, next is extended surface elements, next is tube supports, guide and tube sheets, next is burners, chute blowers, refractory, stacks and ducts, structural members, instrumentation. So these are the few important components of the fire heaters. We are going to discuss one by one all these important components of the fire heaters. The first one, tube and pipes. So it is considered as a very important part of the fire heaters. It is the heart of the heater, and normally the size of the tubes are in the range of 50 millimeter to 150 millimeter. This is the range, 50 millimeter to 150 millimeter. That is the size of the pipe, and the wall thickness of that pipe is 40 schedule to 80 schedule. That is a standard method. And then these tubes are spaced as 2D. So 2D, D is here for the diameter. This is a 2D spacing. What it means there, suppose this is a one tube and this is a second tube, then the distance between these two tubes we can measure through the central point. This is a center point of first tube, this is a second tube, and this is the distance between the two pipe. This is the way how to basically find out the tube spacing. Now how tubes are connected, they are the seamless steel tubes that are used in the heaters. No welding basically there. Materials of tube ranging from carbon steel to chromium, molybdenum alloys to stainless steels, and these materials are basically selected on the basis of certain reasons. We cannot take not basis of the cost, but basis of the some characteristics. For example, corrosion characteristics of the process fluid, high temperature oxidation resistance of the material, tube metal temperatures that govern the creep rupture strength of the material. So these are the few basic characteristics, are important points that need to be taken out. These are a few figures for the tubes. These tubes are basically required in the furnaces. So these are the different shapes of the tubes are basically. Now comes the second point, that is the manifolds. What is the meaning of manifolds? So manifolds are basically a flow distribution pipes and normally provided at the inlet and outlet of the furnace. Inlet and outlet means at the inlet there is manifolds and outlet. At the inlet what happened? It is distributed, and the outlet it is accumulated. All the distributed pipes are accumulated in a single pipe with the help of manifolds. And for the more than one fluid pass, parallel streams flow in the heater are used. Manifold arrangement is carefully selected to assure the equal flow in all passes. Obviously that is a necessary thing. That's why we need a manifold. These are a few pictures and diagrams for the manifolds, where these manifolds are used in the furnace. Flanges, we all know about the flanges. It is used for connecting the two pipes. So at the heater inlet and outlet terminals we require the flanges because connections are there, so from the inlet side as well as from the outlet side. And there are so many types of the flanges are there. So we can use raised face ring type joint flanges, but if there are very high pressures, so at that time normally the welding with the pipe is used rather than using the flanges, and the material of flanges are normally same as that of the tubes, so there are no difference in the materials. These are few diagrams of the flanges. We can see how these flanges are connected with the pipes. Now next part is extended surface elements. Extended surface elements, basically we have discussed earlier that in the convection section the heat is transferred from the flue gases mainly by the convection mechanism, and we know that for the convection there are very important thing, and the flue gas film coefficient is very low. So the second option that is left is to improve the surface area. That's why extended surface area is required, like struts, like fins. They are used to increase the turbulency as well as increase the heat transfer area per unit of the tube. So either go for the struts or you can go for the fins type, struts type. Both are used, but fins have their own advantages. For example, it have a high heat transfer area available per unit length and is less expensive and more compact compared to the strut tubes. And the second advantage, for a given heat duty, fin tubes result in a lesser pressure drop on the flue gas side as compared to the stag one, and allowing the small stags and hence reduce the overall investment. So that is the advantage of the fin types of the extended surface area. These are a few diagrams. These are the fins available. This is without the fins, this is with the fins. Fins are available, the area, extended area is there, more area is available here. These are the struts available with the pipes. So we are normally prefer the fins one. Come to the next one is the tube supports, guides and the tube sheets. So heater tubes are properly guided and supported by a suitable casting to take care of the dead loads of the pipe. That's why we need the supports of the and guides or the tube sheets to maintain the tubes in the furnace, and also we take care of the expansion movement of the tubes also. So if we think about the radiation section, so vertical tubes are supported in one end while the other end is guided to take care of the tube expansion. As far as the horizontal tubes are concerned, so in the radiation section they are supported by wall support at interval of 3 to 5 meters, and in the convection section we normally provide the tube sheets in the convection section. These two are the example for the radiation section. So depending on the tube length, the convection tube banks may have one or more intermediate tube sheets. These are the supports, these are the example. These images shows here tube sheets on which the tubes are supported. So the next one is burners. We all know that burner is one of the very essential part of the heater. In fact, the design of the heaters are depend on the performance of the burners. So normally burners are gas firing type. Gas firing means you can use the natural gas as a feedstock, as a fuel for the gas firing. Oil firing type means the burners where the fuel is fuel oil. So gas firing, oil firing, we all know about it, because normally in our day-to-day life we have gone through these two types of the burners. The third one is the combinations of gas and oil simultaneously in any ratio. The burner should not only ensure the complete combustion but also ensure the proper flame pattern. That is the very important thing. So two functions are going on with the help of the burners. So depending on the type, there are gas nozzle or the oil gun that is available in the burners, and oil is generally atomized by the steam. So it's steam atomization of the oil in the burner is very important. We have two options, either we can go for the steam atomization or the mechanical atomizations. But in the steam atomization, it is give a better sharp flame, keeps the oil tip clean and offers the wide turn down ratio as compared to the mechanical atomizations. So that's why we prefer it. This is the one diagram, simple diagram of the burners. Now come to the next one, that is the soot blowers. They are provided to blow out any soot and ash deposits that accumulate on the convection tubes. So cleaning of the tubes are basically done depending on the individual cases. Either fixed rotary type soot blower or the long stroke retractable soot blower are used. That is the one that travel into the convection section, and retracts are used basically. So these are soot blowers. The soot blower can have either steam or air as a blowing medium, and generally steam is preferred medium. Because why we need a steam? There are advantages of steam. Now let us look at one video where the soot blowers are used for the cleaning of the soot. Just making the speeds. Now these are the different components of the soot blowers, and you can see that these are the different parts, and this soot blowers working is here, how they are used here, and they are installed at the outside of the furnace. At a very high temperature of the furnace, they can easily clean the soots. So this is one example where it is installed at the inside of the furnace. There are soots, and with the help of steam they are cleaned. So in this way soot blowers are functioning. Now the next part is refractory lines or refractory bricks that are used in the furnace. So refractory, what is refractory? Basically, refractory is any material that can withstand at a high temperature without softening or suffering a deformation in the shape. So that is an important thing, and in fact they are essential material for construction of metallurgy, energy, chemical industries. Without their use, it is impossible to maintain the required temperature. So we need the refractory. The first objective to confine the heat, that to resist the loss of heat. So refractory is also used as a insulation system for our furnaces. The second is to resist the corrosive action of the molten materials or the flue gases, or any corrosive materials are there if flue gas within the flue gases. So refractory are basically totally inert with respect to the corrosive materials. These few diagrams are representing here how the refractory are used inside the furnace. So they are normally very commonly used bricks type. So what happened, the flue gas temperature inside the heater are higher. In order to cut down the heat loss and have a tolerable outside surface temperature, the wall of heater are refractory lined. Means we have to maintain the refractory materials inside the surface. Either insulating crucible or insulating bricks or block refractory system can be used. So we have discussed about the insulating bricks earlier in the diagram, how the insulating bricks are there. This is a very important point that you should remember, that heaters are designed to have a slight negative pressure. This is a slight negative pressure in all parts of the furnace. So negative pressure means low as compared to the outside, to allow the cool ambient air flow in the heater through any leaks in the heater shell. So what it means, that cool ambient air flow inside the heater. Obviously if the heater have a low pressure as compared to the ambient air, so if there is any leakage, so these cool ambient air will obviously go inside the heater. So why we need this one? What is the advantage? Suppose if this is not there, a positive pressure is there in the heater, what happens? It would force the hot flue gases to leak out, thereby overheating and damaging the refractory system as well as the structural members. So that is a very dangerous thing if the positive pressure inside the furnace is there. Stack and ducts, the next one is so normally one or more than one stacks are provided either on the heater top or on the ground. So normally heater top is there. So stack provides the necessary draft needed to overcome the convection section flue gas pressure drop, and also serve to discharge the hot flue gases to the atmosphere at a higher level. So two purposes are there. One is to discharge the hot flue gases to the atmosphere at a higher level, at a higher height, and the second is to maintain the draft in the convection section. So we'll discuss about the draft in the next lecture or in the coming lecture. So ducts, the second thing, ducts, they are provided to convey the combustion air to forced draft burners and the flue gas to stack air preheaters. So ducts are there, they are basically channelizing all these things. So these are the few diagrams for the stack where the flue gases are taken out. Next is the structural members. The structural members means supported by structural members like columns and beams, also accommodated like platforms, stairways, ladders. So these are required in the any heater, in fact for any structure these are required. Instrumentation, this is the last one. For good operations we need a minimum instrumentations. For example, on the gas side, thermocouple points are provided to measure temperature of the flue gas entering the and leaving the convection sections. Process fluid side temperature points are required at inlet and outlet of convection section and outlet radiation section of each passes. At these points, suitable pressure gauge can be provided to measure the pressure drop. So these are the important thing that is required. So these are the few basically instrumentation diagram. So this is the last one. So these are the few important components of the fire heaters. Thank you very much.